Phase diagrams, part 1. In problem 1, we have a specimen of soil that has a total volume of 1 cubic foot. When it is wet, it weighs 120 pounds. When it is dry, it weighs 110 pounds. Now, if the volume of solids is 0.6 cubic feet, and we know the unit weight of water is 62.4 pounds per cubic foot, we can calculate the volume of water, the degree of saturation, the void ratio, and the porosity. The weight of water is simply the wet weight minus the dry weight. In this case, that's 10 pounds. And once we know the weight of water, we can divide it by its unit weight to get its volume. And that turns out to be 0.16 cubic feet. We still need to figure out the volume of voids, but that's simply the total volume of 1 cubic foot minus the volume of solids of 0.6 cubic feet, which gives us 0.4 cubic feet for the volume of voids. We can now calculate saturation, which is defined as the volume of water divided by the volume of voids. In our case, this is 40%, or 0.4. We can calculate our void ratio, which is defined as the volume of voids over the volume of solids, or 0.67. Similarly, we can calculate porosity, which is the volume of voids over the total volume. This comes out to be 0.4 or 40%. Alternatively, we have a formula that relates porosity to void ratio. And if we insert our void ratio into that formula, we again come out with a porosity of 40%. In our second problem, we're given a phase diagram in which we know the total volume, the volume of air, the volume of water, but we don't know the volume of solids. And we're asked to calculate the porosity, the void ratio, and the degree of saturation. The volume of voids is simply the volume of water plus the volume of air, or 1.1 cubic feet. The porosity is, again, the volume of voids over the total volume, and we can calculate that as 0.367, or 36.7%. Now, for our other calculations, we need to calculate the volume of solids, and that's simply the total volume minus the other volumes that we know, and we find out our volume of solids is 1.9 cubic feet. Knowing this, we can calculate the void ratio as the volume of voids divided by the volume of solids. That turns out to be 0.59. Saturation is again the volume of water over the volume of voids, or 36.4%.